Hi, Manuel Orduño from Particle here. Welcome to the second part of the Designing on Particle, the data pipeline video, in which we'll work on a practical example of the topics we learned about in the first video. If you have not watched part 1 yet, I strongly recommend you do so first. It'll help you follow along as we build out the application. For this example, we'll create a simple dashboard that displays sensor readings sent from multiple devices using Datacake, a low-code IoT web platform. We will also use Postman to send commands back to the devices using our Device Cloud API. This is representative of a common remote monitoring and control solution. As we build out the example, we will use the concepts we covered during the first video. Using particle.publish in our firmware to securely and efficiently send data to the Particle Cloud, going over tips and best practices to publish data. Setting up a webhook integration in the Particle console to route the sensor data out to Datacake, where we'll learn about the template engine and how it can be used to format your payloads. And finally, we will go back to our firmware to set up a particle.subscribe handler to receive commands. In this scenario, we will use Postman to publish the events that the devices will subscribe to. In doing so, we'll briefly talk about the Particle API user tokens and how they can be used for secure cloud-to-cloud communications. By the end of this video, you'll have working knowledge to build a scalable and secure architecture to send and receive data across thousands of devices. Throughout the video, I will be sharing additional resources that will help you dive deeper into these topics as you work on your own system design. Let's get started. Let's begin by looking at the following firmware. It's a simple application that publishes dummy temperature readings every 3 minutes and listens for a command from the cloud to increase the publishing frequency to every 10 seconds. This could be helpful in situations where you need near real-time information but just for brief periods of time, optimizing your data usage. It all starts with our new project template, which by default gives us a good file structure and enables recommended settings like threading mode and the serial log handler. We then add a couple of variables to handle the publishing schedule. I'll skip the setup block for now and go straight into the loop block. As you can see, all it does is publish sensor data according to the frequency we defined. Keep in mind that you should always ensure you're online before calling particle.publish. Otherwise, your application could hang for multiple seconds before resuming execution. For more advanced time scheduling needs, take a look at our guide in the docs. Down below, you can see the function that creates dummy temperature readings and, most importantly, the publish sensor data function. As the particle pubsub engine is text-based, we're able to use well-known structures like JSON to format our payload. DeviceOS has built-in support for JSON, taking care of escaping double quotes and formatting the object. It is best practice to keep key names short, so we'll use the letter T for temperature and set its value to the number returned by our read temperature function. Later in the video, we will see how we can expand and transform our key names to make them clearer or to comply with your end system's requirements. As you can see, it's very straightforward to add additional readings to the object. For example, humidity. JSON Writer supports complex structures like nested objects and arrays. See the reference for the full API. Finally, at line 86, we have the actual publish, a single line of code that provides a simple, secure, and scalable path to the cloud. A good naming convention is to use the platform -event scheme. This could help structure your integrations if you added additional events, such as alerts or diagnostics. Now that we have a better understanding of the firmware, let's go into the console to see the events come through. For this application, I've created a product in my sandbox, added 2 Photon 2s to it, and flashed them with the firmware we just saw. Here in the events view, you can see the different events going through the stream. For example, the Datacake sensors event sent by my 2 devices every 3 minutes, as well as any other events sent by our devices or other sources. In this case, for every event sent by our devices, we get a response from the Datacake platform. And later in the video, we will also see an event come through once we go over Postman. While all of this is great, it's important to note that Particle does not store the payload sent by your devices or any other event flowing through the stream. As soon as I close this tab, all these events will be lost. This is why you need to route the data into your own systems for proper storage and processing. Let's go ahead and see how this is done by reviewing my Datacake integration. To do so, let's go to the Integrations tab. Here you'll see a table view listing of all the different integrations you have set up for your product, and a bird's eye view of relevant information like its status and today's traffic. Let's click on our integrations to see its details. You can see here the specific details of my Datacake integration. Depending on the end system you'll be using, you'll likely have to modify settings like URL, request type, or headers to match your end system's requirements. Take a look at the JSON data. I want to call out a very powerful feature of our webhooks, mustache templates. Anything in double or triple curly braces is a variable, and you can use this to expand or filter data to suit your exact needs, as well as using pre-built variables. Let's see how this works in practice. This diagram shows how the payload that gets sent to the end system is defined by the template of your integration, where variables can be used to substitute data both coming from your devices or from the predefined Particle variables. While this example is simple, the template engine is very powerful and can be used to create very complex structures. Please refer to our docs for more information on this. Let's now go to Datacake to see how it all ties together. Here's the simple dashboard that shows the latest temperature readings coming from each device. Every time one of my devices publishes an event, a webhook with a formatted payload is sent to Datacake for storage and display. Since it is likely that you will be integrating with a different system, I will not go into the details on how to set up things inside Datacake. However, it is certainly a powerful tool, and if you're interested in learning more about this integration, they have a great guide on how to set up Particle devices on their platform. Let's go into the final part of our solution. Up until now, we've worked with sensor data going from devices to the cloud, so it's time to see how the reverse works. As we saw in the previous video, there are two ways in which you can send data from the cloud to your devices, using either the function or the subscribe API. For this example, we will use the subscribe API as it allows us to reach our two devices with a single command. To emulate a control dashboard, we will use Postman, a platform to build and test APIs. Particle offers a Postman collection that greatly simplifies getting started with the Particle Cloud API. Finally, we will quickly go over API users, a special kind of account in our platform that's useful when working with cloud-to-cloud integrations or other programmatic tasks. We will create a tightly scoped account and use its access token to authorize our requests to the Particle Cloud API. Let's begin by going back to the device firmware. Let's go now into our setup block, where we register the subscribe handler. With this line in place, anytime an event with the name real-time gets published to the product stream, the device will run the command handler function. If we scroll down to the function itself, you'll see that we're only parsing the payload for an on or off message that will in turn adjust the publishing frequency variable we defined. We also toggle the Photon 2's built-in LED as a visual indicator. And that's all we need to get reliable messages coming from the cloud. Note that for this example, we had a simple structure for both our event name and data. However, the Subscribe API has advanced capabilities to support more complex commands and more granular device targeting. For more details on this, please refer to our guide in the docs. Let's now go to Postman to see this in action. Particle's Postman collection gives you a great way to get started with the Device Cloud API. For our application, we need to publish a product event API. I've gone ahead and created a copy to fill out the required fields. There's 3 sections you need to fill with your own data: the product ID in the URL, the event name and data in the body, and the access token in the authorization section. The product ID can be quickly found at the top of your console when you're working inside the product. Let me grab the ID and put it in the URL. For the body, we fill out the event name with real time, and we'll start with on for the data field. And finally, for the access token, let's go to the particle docs. We have a very handy web tool to simplify the API user creation process. Make sure that you're logged in with the same particle account you're using for development. Select the proper product, give it a friendly name if you want, and choose the right scopes. For our application, we only need the events sent scope. As you can see, API users offers significant security benefits due to its least privilege needed nature, making them ideal for programmatic cloud-to-cloud integrations. Let's go ahead and click the Create API User button. I'll copy the returned access token and paste it in the appropriate field in Postman. Now that we have everything in place, let's click on Send to publish the event to the product stream. We should be able to see it come through in the console, and our devices should start to publish readings every 10 seconds. And there it is. Our real-time event came through, and with it, our devices switched to a real-time mode. I hope that this example made sense. We covered a lot of topics during the video, but you should now have a better understanding of how to establish a solid bidirectional communication between your devices and your cloud. Particle's end-to-end IoT platform takes care of complex device connectivity infrastructure, letting you focus on what's valuable for your business and your customers. Thank you for watching. Until the next time.